Okay, so next up we've got C2 Power System Operation and Control. So my understanding is that we've got Mr. James Guest who will be presenting this PowerPoint, is that correct? Yep, cool. Okay, there you are. Fantastic. So I'd like to invite James over, please.
Thank you very much. My name's James. I'm the NGN liaison for C2. Unfortunately, Shart decided to change career and go join a jazz band, so I'm here instead. I'm just kidding about that. But I'm going to take over for him today for C2. So what is the C2 panel? Where we're really interested in the here and now of the electrical power system. So looking at real-time operation of the power system. So we look at our main objectives when operating the power system. We want at least in Australia, we definitely want a secure, a reliable and an economic power system. We want to operate our grid within those parameters. And so what we do is we first look at, well, what are the consequences if we don't do that? Well, what are our consequences? The system can fall apart. System disintegration is a very euphemistic way of putting it. But lots of things can go wrong in many very different ways. And we want to understand all of those ways that can happen so we can make sure in the here and now it doesn't happen. Things like equipment damage. We don't want assets to be damaged. We don't want them to be destroyed. We want to make sure that they're all nice and healthy and they continue to live long, happy lives. The same with the humans that work on those devices. We want to make sure they live long, happy lives as well. So we want to make sure that everything is tickety-boo and that nothing goes wrong. Fingers crossed. So how do we do that, particularly with C-grey? Well, we look at factors like the technical factors. So what is the technical envelope of our power system? How do we define our limits? How do we define what our issues are? What are our human factors? Well, we don't have computers running the entire power system. We actually need real-time 24/7 control rooms, and they need to be managed, just like any emergencies or real-time services. And institutional, basically the support for those control rooms and those services. So our key term we have here in C2 is what we say operationalise. We basically take advice from many places, industry standards, government bodies, but also importantly industry and international forums like C-grey, and we operationalise the advice found within there. So concepts from academic use, study results, concepts, we take them all and we operationalise and put it to use in real time in a power system. So in Australia, these are our key areas. There's 3 key areas. First being RTO, real-time operations. Everything associated with running a power system in real time, tools, people, etc. We then look at also the near term, because to operate right now, we also want to know what's coming up over the hill. So we look at what we call operational planning. What's going to happen in the next 30 minutes, 1 day, 7 days ahead. So we know what's coming and we can prepare for it. And then finally also look at any related things like the infrastructure and the human resources. So some of the key areas we look at, we're focusing on in the C2 panel in Australia. So one of the big ones is the tools, the man-machine interface, how we interact with the power system. One thing I like to say is visibility is everything for a control room. We want to always have visibility, but we also want to know what we need to monitor as well. So looking at how we get the visibility over the power system and how we make informed and rational decisions based on that information in real time. The control room infrastructure, of course, things like your SCADA systems, your software, tools, algorithms, state estimation, contingency analysis, things like that. The actual physical operation of the power system in real time, how we run our 24/7 control rooms, how we train and assess and make sure our operators are competent to run the power system. But, you know, for all aspects of from distribution, both up to transmission and, of course, AEMO as well. We then look at the short-term operational planning, but also follow-up, because if we do have events and we do have failures, we want to make sure we learn from our mistakes and learn from our failures. We have something at AEMO we call a just culture, where we don't assign blame to anyone. Instead, we aim to learn from our mistakes. And that's what we do, is any time we have an event or an incident, we will also do follow-up and analysis. And a big part of that is working with CGRE as well. For example, the large disturbances workshop that was mentioned that happens at Paris is a big part of C2, is analysing events that have happened both in Australia and outside of Australia, look at what's gone on, and understand and figure out how we can do things going in the future. And then finally, going to the human resources and the people, making sure that the operators, we have training and certification as well. So these are the working groups. So there's 6 currently active working groups after the C218 working group finished up last year. There's some quite interesting ones. Particularly interesting are some of the issues we're looking at the moment that are key challenges in Australia. For example, Greg's working group there on operational strategies to manage power system minimums, looking at, well, historically, we've been having issues with the power system at high demand. That's not so much an issue anymore. Now the issue is at the low demand, because we don't just have technical maximum limits, we also have technical minimum limits. And understanding what those limits are is a big challenge, and something that we're doing now on a day-to-day basis. Like even as recent as last week, we were having to manage minimum power system issues in South Australia. Another working group, a brand new one that's just formed this year, the Wide Area Operational Security Systems to enable the energy transition. That's a brand new one that's close to my heart because it deals with wide area monitoring. But it's quite an interesting one because it's not only looking at, wide area monitoring system like PMU and WAMs and whatnot, but it's how do we operationalise the information that comes from those systems? How do we make informed decisions about that? That's not something we've really investigated. We've got the technology, we know it works, we know it's great, but then how do we make decisions based off of it? That's one question we need to answer. So that's going to be a really interesting working group going forward. And we've got an excellent Australian and NGN member on that working group, which is really exciting to have. So these are our 3 preferential subjects. So number 1, advanced decision support, training and skills for control room personnel, because I think everyone's in agreement, being a control room operator is getting harder and harder. The system is becoming more and more and more complex. There's more and more stuff to do, more and more things that go wrong. So part of what this is making sure that the people have the right skills to be able to manage the ever-increasing complexity of the grid, but also that they have the tools that they need to do their jobs. I'm sure lots of you are operating on, probably 10, 20, 30-year-old software and systems. So how do we make sure our tools stay up-to-date and relevant and useful and allow our operators to do their job effectively? And what's also included in that is how do we also do that with our operational procedures? Because in the control room, procedures are everything. They're basically our rule book for how we run the power system. So we want to make sure that our procedures, tools and processes are all up to date and reflect any of these emerging conditions and our historical conditions as well. Number 2, maintaining operational reliability through flexibility. This goes into how the power system is changing dynamically. We've got a whole bunch of renewable and variable resources. How do we manage that in a real-time perspective? How do we manage that with the energy market or with our central dispatch, with things like voltage control and stability, not just from a planning or from a planning or a connection basis, but from a real-time perspective? How do we manage that? And that also goes and touches back on the tools and processes as well. Finally, power systems dynamics and control in operations. So this is a joint one with P4, and this is going on to looking at, well, what are the challenges that are emerging on the power system? What are some of the issues we're starting to see that we've never seen before? One of those things that I just mentioned before was the minimum system demand. We're starting to see that's a big issue. Other things like system strength is a big issue, low inertia, power system stability issues, particularly to do with inverter-based devices, oscillations, small signal oscillations, with decreasing number of synchronous generators, all brand new phenomena that we're starting to see. And thanks to people, smart, clever people in C4, we're starting to understand the physics and the maths behind those. But what we're trying to do in C2 is figure out how do we take that information and operationalise it? How do we turn it into information for the control room? And that's something we're really focused on here in Australia, C2. So on to the C2 panel. What are some of our achievements? Well, firstly, this year we had our general meeting at the Adelaide conference, and we had new representation sign up from Transgrid and AusNet, which completes representation from every major transmission provider in Australia and New Zealand. So we now have full representation on the C2 panel, which is an excellent achievement for us to have. At the end of last year, we had the Seagrey Australia Power Electronics and Power System Integration Seminar, again touching on that last point I mentioned, converging on the new power system stability phenomena and how do we operationalise that in a real-time sense. That was in Sydney, and we had a lot of excellent presentations given in that seminar. And finally, we had 2 technical brochures that were published. The first was a joint working group on the impact of market interventions by system operations during emergency situations. And the second one was the impact of offshore wind power hybrid AC-DC connections on system operations and system design.